Hello and welcome back. Thank you so much for staying with us today. Next, we've got a fabulous headliner panel on a topic that's close to all of our hearts, championing a collaborative approach to data. How can we source the data our algorithms need? Here to share a wealth of knowledge, I'm delighted to introduce our panelists, Dr. Adrian Pearce, Group Chief Data Officer at Credit Suisse, and Amir Danak, Principal Data Scientist at Quantum Black. Sadly, Damien Boselager, who's a member of the European Parliament, is unable to now join us today. But I'm delighted to be handing over to Viktoriia Gerukh, who's the CEO of uTrigg, who will be moderating this session. Viktoriia and your wonderful panel, over to you. Welcome.
Thank you so much. Hi, everyone. We have today an amazing two speakers that will share their huge experience. So you're so lucky to hear their experience, their advice, and their insights. Let me introduce Dr. Adrian Pearce, Group Chief Data Officer from Credit Suisse, and Amir Danak, Principal Data Scientist, Quantum Black. So they will talk about the trends in AI, what obstacles data scientists are facing every day, and what other interesting tips in the tech in their minds every day. So welcome, each of you.
Thank you.
Thank you, Victor.
Would you like to start from such? What are the best sources for data right now, and what kind of data sources will be in the future? Just in order to start our small talk.
Okay, so I think if we think about it, think of it as a hub and a spoke. So I work in a bank. Think of it the hub of what we have, very, very well governed client data, product data, transactional data. It's governed, it's structured, it's managed internally. But then think about a series of spokes, and those spokes are where we're adding to that information with derived information and external information. And that allows us to get much more depth and context on our clients or our trading activity or whatever. And so I think this need to know your client is very important for us. So what we do is we add to a very central piece of well-managed and very tight information, external information. That external information comes in many, many sources. It could be around about an individual's connections to other individuals, connections to companies, positions on other companies. It could be about specific deals. It could be about regional activities, negative and positive sentiments in the market around certain things that are happening, or known affinities. All of those things can be added to the information that we have to give us that much better context. And that's super important for us. So it's really about joining these two things together, one that we control and we manage, and then other things that we can add to relatively easily. So I think those are what I would describe as the best pieces of information for us, without going into too specific details about, particular affinity sites, etc.
Okay, thank you so much. Amir, could you add something to that, like what kind of internal types of data you have, or what kind of external data you can have as a data scientist?
Absolutely. Great points Adrian mentioned about the diversity of data and how important it is to improve the quality of our models. I want to take it a bit more into an extension. Like, we usually talk about data as in the data that we use to build our models, like the training data that we use to find the patterns that happened in the past to build really good solutions. To build great solutions, we also need data from humans, experts, that we need to embed into our solutions. This is an area that we see that we actually need to augment machines and humans, build hybrid systems like human-machine hybrids that actually generates great outcomes. We see the use cases in fashion, in transcribing live streams that humans can actually augment the value that the machines can bring. So this is another set of data that we need to talk about. Also, data about how the models are perceived by humans. So what can we do to increase the adoption of the solution, so assuring that we trust the predictions that our algorithms make. So, for example, in the areas of explanation, what we need to explain so that we increase the adoption of our solutions. So to sum it up, we need data and a diverse set of data to increase the quality of our models. A majority of this, a majority of the efforts that we do today is about creating these heterogeneous types of data, as Adrian mentioned, internal and external, that can improve the quality of the model. It provides perspective all around. But we also need data to improve the validity of our models, to improve how it is perceived by humans, like behavioral analytics, psychology type data, so that people trust our models better, and they will be adopted across more industries.
Amazing points. You just go straightly to the next question that I have in my mind. As Adrian mentioned, that there's a lot more types of data, like internal, external, you will have. So you have this KYC, like know your customer attitude, that is crucial for business. And Amir indicated that you need also enhance the data from a perspective of a human, not only some databases that were stored like from the old periods, but also human can enhance it. So my question is how we can be, as a data scientist, in line with all of GDPR things, because we need the more data from customers, the more transparency we need to give to our customers. But there is a lot of checkboxes that they need to put into. So that's why it can be tricky for online customers. So we could get a lot that we would need to. So how to make it balance into giving all the GDPR rules to be in honor, and from the other side respect the online users and the humans that help us to gather all of this data. Your thoughts about that?
Shall I go first this time, and then after this you go first, Amir? Okay, but we'll share the honors. The GDPR rules are very clear, and consequently, from a GDPR perspective, we follow those rules. There are lots of extra things you can do with client consent, and with client consent there is a breadth of things that you can do. Once you have that consent, you have to be very careful how you operate. You have to operate in the client's interest. You have to be transparent about what you're doing, and you have to have their not just their consent to store some data, but they ought to really know what you're doing with it as well. And so that's a very important piece of how we operate. We're very particular. We're a bank, so effectively the integrity and how we handle our client information and how we treat initiatives like GDPR is super important to us. So following the rules is number one, but then with client consent, there are a lot of things you can do once you have the trust and the partnership of your clients.
Okay, thanks. Amir, your thought about that?
Yes, transparency is key. As data scientists, we need to make it very transparent how the user data, how we're using every piece of data, and what is the benefit that the user gets by sharing that data. We should also provide control to the user to decide what part of data they want to share and what is the benefit that they gain out of it. It is additional complexity that we're seeing that by the maturity of AI solutions naturally happens. I would also say that there are trends to increase privacy, increase the how we share private data while we build better algorithms. For example, there's promising trend in federated learning, where we have algorithms moving from data center to data center and learning without that data leaving that local data center. So the algorithm gets trained, the parameters are updated, the updates are sent back to the central system and immediately averaged and integrated with the previous learnings. These are great solutions for working with private data without sharing the sensitive information. So complying with the rules, only sharing what is needed to be shared to have better solutions. But still, it comes down to being very transparent. what are we using the minimum data that we actually need. So this is around those processes, so that we share only the learnings from the local data, and also giving control, so making sure that it's very clear that that solution is bringing, and the user has full control over their own data.
Amazing. Thank you, Adrian. Thank you, Amir. And as you touched a little bit about things that I would like to ask you about the trends and AI. So, Amir, could you be the first one to answer that? What kind of trends you're seeing? So what kind of technological advantages tech will appear in order to that data science could use it for the benefits of the businesses?
Yes, definitely. This is a very exciting question because, well, we are really in the beginning of the journey. We have seen AI solutions adopted in some work streams really well, in some domains really well. We all use virtual keyboards on our smart screen. We don't even think about this is an AI solution. But in others, we are still in the beginning. So there's a lot that is happening. One is around the decentralized machine learning algorithms, as I mentioned. So instead of bringing all the data into one place, can we actually build algorithms that are learning over time in iterations? This is super interesting. The other one that I am really excited about is graph representations of the data, understanding the connections between data points. We have all understood that there is a lot of value that we can get by bringing different perspectives of data together. So really explaining how things are connected, breaking the silos by explaining how we're using each of the data sources and how they're connected, what our algorithms actually learn from this. So these are the mega trends that I see that are already happening in terms of really leveraging heterogeneous data sources and building better solutions across the board, across different industries.
Amazing, amazing. Adrian, your thoughts on this topic?
Yeah, I would agree with Amir, particularly around the graph representation. It's so important. We heard, if you think back to certainly in my childhood, people talked about the butterfly effect. When you get a graph representation, you're able to see very, very real implications of things and connections that were not obvious from the data sets that you put together. One of the major things that I think we're starting to see now as well is looking at our algorithms and making sure that we understand what our unconscious biases are in those algorithms. Are they treating certain demographics particularly? Are they looking at certain genders in a particular way? Things that we didn't think about when we started to look at them, but then when you look at the underlying rules that you didn't understand but start to become apparent from what's happening, you have to make sure that you're not building in an unconscious bias into your routines. And that whole ethics characteristic is going to be something that's very interesting for us in an AI environment. There are very few guidelines at present, and the more we learn and the more progress we make, the less surprising the guidelines will be when they turn up. And I think that's probably incumbent on our industries to work on that quite hard, because we don't want to get that wrong and we don't want punitive regulation or guidance. So there's a big onus on us, I think, and that's a big trend for us, I think.
Amazing, amazing. Maybe some lines that you would like to generalize during our talk that you feel like you would like to share, but I didn't ask you about during our talk. Amir?
I think the importance and the different role that humans can play in building really good solutions. I think what I would love to talk about is in order to get wide adoption of AI, it's very similar to any other solution. We need to build great solutions. We need to create solutions where the advantage and the benefit is so substantially, considerably outweigh the cost and so that we can take the leap, do the change management, change our culture, and adopt the new solution. Humans play a big role in this, and I think one other area that I'm really excited about is crowdsourcing. reaching out to like a big pool of people, experts, to improve the quality of a particular solution. In some domains where the problems are very complicated, for example, in supply chain, the only way that we can improve the quality of the process, given all the dependencies and all the established processes that are in place, silos of data that we've created over the course of time, we do need the human touch, we do need the human expertise embedded into our solutions so that we can really we can have those great solutions that can improve the process end to end. So I think that it is very important to understand that for the machines to get to the same level of intelligence as us humans, we need to play a bigger role into teaching them where they struggle. And this comes in different areas. Crowdsourcing is one of those processes that is helping researchers and professionals across industry embedding their knowledge into our solutions.
Mm-hmm. Amazing fact. Adrian, what I've missed, what you would like to intensively share with the audience, with your huge experience?
Two things that I would say. In a previous life, I remember once standing in front of a regulator, and the regulator said, "Could you explain your model?" It was an FX model. It had 12 rules to it. We explained that, or the individual explained at a conference that, "I understand my 12 rules." And the regulator asked them, "Do you think you could explain what happened to this particular price?" He said, "That's the problem. In the last hour, I had 40 million events that I processed through the 12 rules with different biases. So I could actively go back through the log and tell you what they all are, but that will take me a long time." Why do I tell that story? It's a relatively simple algorithm, but it learns and it understands, and it does it off many, many passes. So being able to extract some of the key indicators as to what is happening is very, very important. And I think this is probably alongside what Amir was just saying. You need to have people interacting with the models on a regular basis so they understand what's happening and get the outputs out of the model so that people can interpret, refine, and move forward. So I think that's a super important point for us, because it's easy to start the 12 things happening. It's very difficult to learn what happened with the 40 million activities in the last hour. I think the other thing I would say is people seem to be put off or spend a lot of time worrying about the quality of the data. Does it have to be good quality? There has to be data. There has to be a statistically sized sample of it. You're not looking for the quality of the data. You're looking for the patterns that you see in the data. And being able to look for the right patterns with the right use cases is super important. We see internally there's always a constant drive to make sure that the people that are working on the solution are very close to the people that need the answer. So they have to be one and the same almost. So we see this as a very decentralized function. We see it being very close to the users, and we see it being right near to the point at which we want to find the answers. So it's a very hands-on process. And I think that's why we see things like crowdsourcing being super helpful, because you don't need to have 25 years experience. You don't need to have a lot of knowledge. You need to know about the solution you're creating, and you can operate it on many data sets. So I think that's what's really exciting about this area. That there's not a dependency of 25 years of experience, which is super for everybody.
Sure. And by the way, one more question to you, as you have a lot of insights from your experience today, but nevertheless, can you share what business industries are struggling from lack of data, because there is no such thing as some kind of technology that can grasp this data? For instance, maybe data scientists are waiting for quantum computing, or maybe something else. So what business industries are suffering, and what technological things that data scientists are waiting? Like, what will be this amazing point when we will say, hooray!
Well, we're certainly not waiting for quantum computing. That is for sure. When I look at the number of qubits you can put together and some of the solutions it will solve, it will be great in the future. When I look at things like cloud, we're able to more than adequately get sufficient cycles to run the cycles and run the processes and pass the data. So I don't think we're technology constrained in terms of hardware per se. I think it all goes down to the solutions that people are providing and the forefront that we're operating in terms of what are those algorithms, what are those clever techniques that we're doing. And I think you can get that equally from people working in an open source environment and sharing their things as doing it internally. And so I think the more sharing we do and the more common working we do, we'll get there much quicker. But I don't feel hardware constrained at this point. Amir?
Yourself?
This is a very broad question. It's an excellent question. I think all industries, to some extent, as you do more analysis, you discover that you need more data, for example. So as the lines between data science and software engineering becomes really fuzzy, because all of our software now has data and has that level of intelligence. So every step that you make, you answer one question, and then you realize, if I had that additional data, I could actually take it to this extra level. If I had that additional level of computation, I could actually do such and such. So I think while there are some optimization problems that are very difficult, notoriously difficult, and we need a leap in computation to address some of those. Overall, across all industries, we are making really good progress. We're understanding the business problems and where AI can benefit the organization the most. And then we're building solutions and discovering other areas that we can spend more time and energy and developing and collecting data, creating new data points, or connecting data points from different domains and getting the improvement. I see everybody is moving forward, and I feel like this is a continuous effort to increase the quality of our algorithms. Our solutions will become more and more complex. We will add more data to them. We will add additional computation to them. So I think if you ask any data scientist in any industry, they will tell you, oh, if I had that additional data points, if I had that additional computation, I would take my model to the next step. That is guaranteed in every domain. You will hear that. It's just we are all evolving together towards that future.
Okay. Amazing thoughts that we gathered today. And I have some additional questions that like lying in my pocket for today. Do you think data scientists is more like engineers, people who are like to try new tools, new techniques, new technology, or those are people that would like to really cover and bring to the business some kind of really needed solution? So from your perspective, of course, it should be both. But nevertheless, what kind of percentages you see from your surrounding or around you that there is addiction with the business solutions to be covered or addiction to technology?
So maybe I tackle this first. In Quantum Black, we have clear delineation between data engineers and data scientists. We work with our clients across different industries, build solutions, and it is because we strongly believe in the idea of having a strong team. So having a team with some people who are more passionate about technology and infrastructure and engineering, and some who are more interested into the statistics and the foundations and the math and the algorithms that is behind this, with also teammates who are interested more into the business context. Mm-hmm. It's always these three. So you need all these three to build a successful solution. You need to have a proper best practices of software engineering in place, so that we know that the data is provided, that the data is piped in the right way, processed, stores, and we know how to deliver the insights to the end user at the end. We need to have a strong math and algorithm skills to really develop frame this problem properly, find the right solution for it, test the solution, validate the solution, and so forth. And we need to have a lot of business acumen to really understand what is the best first use case. Is this use case a good use case for you, for AI, or should we frame this problem completely differently? Really, all of them. And so, and a team that has all these skills in it is a very, very powerful unit that can work. And from my perspective, all of them can. A data scientist can be passionate about either of these three skills: the technology, the math, and the algorithms, or the business acumen. It's just, and so all of them are great data scientists. It's just, how do you assemble a team that has all the skills? That to me is the key question.
I suppose it will be for some separate panel discussion, but yeah, very, very amazing thing that you mentioned about the team versus the unicorn that have all those skills. Thanks for that. Adrian, your thoughts about like unicorn that have all of these skills and where he is mostly professional at, or the team building?
No, I think Amir's answer was a great answer. You know, we've all seen examples though where in the group you need slightly more business knowledge, you need slightly more engineering because you've never really got the data before, and you need to make that work, or it's just a new algorithm that you're trying out. So I think it's a bit of a balance. It's a real balance, but it's a proper 3 or 5 person legged race, if you like. They all have to be there. I guess it's back to the mythical man month and the surgical team, right? Don't try and do an operation without an anaesthetist, otherwise it's going to really hurt somebody. And I think that's what we're saying here. All parts are important, but there are balances, right? There'll be sometimes where the business problem needs more thought, and sometimes it's the algorithm, and sometimes it's just the engineering of getting hold of that data, loading it properly, and making sure people have got the right access. So, I think Amir nailed it. Well done, Amir.
Thank you. Yeah, any other additional notes that you would like to add, Amir? No? Yes?
No, I think we covered this very well.
Okay, and the last one, I suppose, that we could cover today, what wishes, what ask you could make today for all these data scientists that are together with us as the participants, like what you would like them to working on, like what is the most weaknesses of all data scientists that you see from time to time. You could make it into a wish, like it could be a good if there could be some enhancement in this way, or look in this area. What the last and the biggest advice from your level of wiseness and the huge experience you could share to the data scientists?
The most optimistic, let's end on an optimistic point.
Okay.
Data scientists and engineers and people writing AI models, they're typically not overly protectionist about their things. They're very open about what they've done and why they've done it and how they've done it. And I think that is a super positive theme for us to think about at the end of this discussion. Because as you think about joining pieces of information together and people sharing, it's not really proprietary in terms of some of the information. And sharing it, we make much, much more progress. And we're very open to that. We're very open to trying our best to be as helpful as we can, and particularly along the lines of ethics and some of the complicated things we're going to have to think about. That level of openness and sharing, I think, in our community is really going to help us. And I'm very positive about it.
Thank you, Adrian.
I fully agree. It's also a great note. The only thing that I would add is, to all the data scientists or aspiring data scientists out there, take the lead, try a real problem, join in any capacity that you can, a real problem. And even if it seems simple in the beginning, you will learn all the practical considerations that need to be in place for that solution to have adoption. And you will learn a ton out of this process. And as Adrian mentioned, always, what I have seen in my experience, always every business is open to your ideas and your creative ways of how we can improve it, how we can extend it to the next level, you will learn a ton more from a real world application than a synthesized, a very structured example that you can find. So I encourage you to take that leap and really join one of the and tackle one of the real world problems that we currently have. And we have plenty of them across different industries.
Amazing. Thank you, each of you, for your time, for your energy, for your sharing ideas. Thank you so much.
Thank you all
Viktoriia.
so much. And I believe that you are all staying around for our Q&A session, so our audience will be able to dive in a bit more there. I did particularly really love the thoughts about unconscious bias and looking for patterns in data, particularly with a humanistic approach to ensuring that we're applying technology that is open and free of bias. So thank you very much for sharing those points, and I'm sure our audience are going to dive in. So those of you watching and you would like to join the panel to ask them any burning questions, they'll be in the networking lounge and speaker Q&A room. The link to that room is going to be dropped now into the chat as before on Hopin. Do follow them through. They will have the cameras and audio on again. Don't forget that you can type your questions and they'll be able to read out the answers. We'll be back after a quick